For a given compound, list the decreasing order of entropy for a liquid, solid, and gas. What we know from our pictures of liquids, solids, and gases. It looks like you get 2 questions on this homework assignment. So our picture of a gas has particles that are very far apart, more dispersed. So gas has highest entropy. Gas phase has highest entropy. Because the particles are farthest apart and most dispersed. And again, here's where that idea of dispersal of matter comes in. It is literally farther apart. So, and as you go from gas to liquid to solid, gas will be greater entropy-wise than liquid, which will be greater than solid. And the way this can show up on exam 3 is you could have a specific material and ask which has higher entropy, H2O gas or H2O liquid. You would always pick the gas. And you don't even need numbers. Like on some of the homework questions, you'll have tables like this one, and you'll have values. And let's see, I think there's another one with a table on it somewhere in here. There we go. So if you have a table like this, and you have, do we have anything? Oh yes, H2O gas, H2S, aqueous, and H2S gas. If you have numbers, then of course you can tell which one has the higher entropy. But if you don't, and I don't have to on the exam, or on the homework, I don't have to give you numbers because if it's the same material, the gas is always higher entropy than the liquid. Now let's look at the next one. Which of the following statements concerning entropy are correct? Choose all that are correct. The entropy of a substance decreases as its temperature increases. This is not correct, so false. And what we would say about this is that entropy increases as temperature increases, and so delta S increases as T increases, and colon, because I'm going to tell you why. So what we can think of is as T increases, we know that the average kinetic energy increases. And so particles are moving faster, and even if they are not necessarily farther apart, there will be more, well, this is a good case where disorder comes into play and it's more than dispersal, but you can think of things moving faster. They are more dispersed, but they're also just generally more disordered. So average kinetic energy increases, so matter is more dispersed / disordered, whichever is easier to think about. And my analogy for this, and it's a dated one because it involves going to the movies, but you can imagine going to a movie theater, and if the theater is entirely packed, every seat is taken, and everybody is sitting. And then compare that to if everybody, the same number of people, the same amount of stuff, except everybody in the movie theater is attempting to run at full speed. I would suggest that picture is, so the dispersed is harder to think about, but it's certainly more disordered, and that the entropy is larger. And I guess the one thing I should do is, since there are actually just entropy values, I should take away my delta here, because there are just entropy, just entropy values. So yeah, so those are two, and this is the homework question about trends in entropy. Any questions about these two or anything else?